All right, what's up, guys? Today we're doing a little two-part 9.2 video. This is the first one. So if you see two videos for 9.2 and you get confused about which one, this is the one you should be watching first. All right, now this is such an important section. It gets two different videos, and you know what? What I'm about to show you in this video, you can take this, you could use it for pre-calc, for calculus, the little special things that we're going to learn here today are going to stay with you for the rest of your mathematical lives. That should be exciting. All right, so check us out. The, uh, the basis of today comes from, we're still talking about right triangles, of course, and you guys know from Pythagorean theorem, yeah, you'd be all over that. No worries. Pythagorean theorem, you can solve for the value of x like it ain't no thing. But what happens if you get a situation like this? Everybody gasp. Oh no, what are we going to do? Well, special right triangles show you what to do whenever you're only given one side of the right triangle and you don't know what the other side is, the other leg, and you're looking for a third side, in this case, the hypotenuse. Well, what we're about to see is as long as you know that you have a 30, or maybe that would put a 60 up here, or there are some other special cases too, well, you can actually solve for the value of missing variables whenever you're only given one side of the triangle. And again, that's a major so let's see what we got. All right, now the purpose of this video is to not just jump straight into the lesson from the book, but to show you why this works and where it comes from. So 30, 60, 90 rules, here we go. So when we talk about 30, 60, 90, well, that's how the triangle breaks down. You know it's going to have a 90-degree angle because it's a right triangle. Well, the other two angles, if they are 30 and 60, then some special rules apply. So let's take a look. Let's, for instance, the background of it starts with an equilateral triangle. So say I got myself an equilateral triangle, 4, 4, 4. All right. You guys know that it has 60 degrees and all the angles all the way around to be equilateral. Well, if you split this up, if you split the equilateral triangle, drop an altitude down, and what happens? Well, you bisect this top angle, so you got 30s up there. So what it creates is a 30, 60, and of course we have a right angle here, 90 right triangle. Now, back to our rules from the first semester. If you bisect an equilateral triangle, the angle at the top, you're also going to bisect the bottom side. So the 4 turns into a 2 on the bottom. All right? So now you can just use Pythagorean theorem to find the height of this triangle. So we're not going to have to do this every time, but I'm just showing you where the shortcut is coming from. So let me work it out for you here. So I'm going to have, again, I'm going to try to find what this height is, knowing that I have a right triangle right there with a 2 as one leg and 4 as the hypotenuse. So I have h squared plus 2 squared equals 4 squared. So h squared, that's 4 minus off of the 16, that would be 12. So then when I take the square root of both of these, again, break this down, so that becomes square root 4, square root 3. So the height in this case would be 2 square roots of 3. So that would be 2 square roots of 3. So if we notice, the hypotenuse was 4, the smallest leg was 2, and that's the side that's opposite this 30 degrees. So if you take a look opposite, then opposite the 30 you have a 2, and opposite the 60 you have a 2 roots of 3. All right, so now check this out. Remember what that was. Let's change this 4 to a different number, and you'll see what the relationship was. All right, let's change the 4 to a 10. And that gives me 10s all the way around. So when I cut the 10 in half, it gives me a 5. So now let's solve for h now. So the h now, h squared plus 5 squared equals 10 squared. So h squared, so 25 off of 100 is 75. Square root both sides. H equals, break this down, root 25, root 3. And I get 5 roots of 3. So I can go on and on all day like this. The bottom line that I want you guys to take from this or to recognize is that when this bottom side opposite 30 was a 2, the answer was 2 roots of 3 when I found the height. When this bottom side was a 5, the height was 5 roots of 3. So the shortcut, when you learn it from your book, actually derives from the fact that it's going to be the side opposite 30, whatever that is, in front of or times the square root of 3. So that should be pretty cool for you. So your hypotenuse gets cut in half to get the side opposite 30, and then you just take that number and you put it in front of the square root of 3 to find the missing leg. So, well, I'm going to hold off on going back until we talk about some more examples. So that is where the first shortcut comes from. You might want to rewind this video a couple times if it's too fast for you. Now, the other special right triangle is a 45, 45, 90. And this one you could still tackle actually with Pythagorean theorem without going through too much, but you don't have to. All right, so I have it drawn here in a square. Then I just draw the diagonal to cut the square up to give me a 45, a 45, and a 90. So let's just pick a number. I'll just keep it simple. I'll go loopy twos for this one. All right, so now if this was the case, 45, 45, 90, an isosceles right triangle, well, you guys know that you could do Pythagorean theorem. 2 squared plus 2 squared equals x squared. So that's 4 and 4 is 8 equals x squared. Take the square root, bust it up, square root of 4, square root of 2. 2 square roots of 2 would equal your hypotenuse. 2 square roots of 2. Well, let's change it up. What if I make it a 3? Let's say this 2 is now a 3. So that puts a 3 over here. So let's see what happens here. 3 squared plus 3 squared equals x squared. 9 and 9, 18 equals x squared. Square root both sides, bust this up. Root 9, root 2. So that is 3 roots of 2. So if it's 3, it's 3 roots of 2. And again, we could go on and on with this pattern, but you can see what's going to happen. Whatever you have as the legs, 3, to get the hypotenuse, don't waste time on Pythagorean theorem. You're in the middle of an SAT and you're trying to find the hypotenuse of a isosceles right triangle. You just know that you take that number and you stick it in front of the square root of 2. So there's the derivation of the 2 shortcuts that we're about to talk about today. So I wanted to have it on video for you guys and not just jump straight into the lesson so you can see what's up. All right, so now, these are the things that you just have to remember as we go through the rest of this year. Again, junior year, senior year, calculus, pre-calc, everything that you guys are going to do. So let's see what we got. If we are given a 30, 60, 90 triangle, so again, you know it's 30, 60, 90 because it has the angles there, 30 and 60. All you really got to do is give you one of those two because you could subtract from 180. The 90 is given for all these guys. All right, so there's 3 scenarios. You could be given the shortest leg, like this first picture. So the side opposite 30 is going to be referred to as the short leg. All right, so if you hear me say short leg, that's also the side opposite 30. So if you're given that, well, you don't have to go through and draw that big equilateral triangle like we did earlier. You're just going to memorize what happens with the other 2 sides. And this one's pretty easy, guys. If you know the side opposite 30 is 4, then I know that the hypotenuse of this thing is 8. It doubles. That's the relationship. And then the side opposite 60, I can get by just taking the 4 and putting it in front of the square root of 3. So these are the shortcuts that you'll have to learn. And again, it goes back to all this madness. The hypotenuse gets cut in half to get the small leg. The small leg gets stuck in front of the square root of 3 to get the larger leg. So you saw how fast we did that. All right, I had the 4, boom, 8, 4 roots of 3, done. The triangle is solved. Now if you're the second scenario, so that was our first scenario. Our second scenario is the longest one. This is a tricky one. If you start out with the longer leg, the side opposite 60, then you got to do a little bit of work. Now think about this logically. You're getting smaller to go to the side opposite 30. The side opposite 60 is bigger than the side opposite 30. So if you want to go backwards, well, up here, to go from the 30 side to the 60 side, we multiplied by the square root of 3. So to go backwards, we're going to divide by the square root of 3. So this will be 4 divided by the square root of 3. Now this is trouble, guys, because you are not allowed to divide by an irrational number. Just like you can't have 0 on the bottom, the SAT's proper mathematical language will not have a radical in the denominator. So you learned something back in algebra that was called rationalizing the denominator, making it rational, making it a rational number. And to do that, you just multiply by 1 in disguise. The value of the square root of 3 over the square root of 3 is 1, so you're not changing the value of this side, 4 divided by square root of 3. You're just making it look mathematically correct. All right, why did I pick the square root of 3? Well, you want to pick what's on the denominator of your original fraction because it's going to go away then pretty nicely. So multiply straight across the top, you have 4 roots of 3. Now when you multiply straight across the bottom, square root of 3 times the square root of 3 is the square root of 9, which of course is 3. So now that is an SAT answer, a quiz answer. Proper mathematical form is 4 roots of 3 over 3. So you can see that one gets kind of messy, but sometimes if this number here is divisible by 3, then you can reduce. Like if it was 6 roots of 3 over 3, you could cross out the 6 and the 3. And we'll get some examples like that coming up. All right, so that's the long one. Let's take a look at the third scenario. In the third scenario, super quick, just like the first one. I'm given the hypotenuse, the side opposite the 90. Well, I know I can go to the short leg real quick, cut it in half. Boom, that's 2. And then how do I go from the 30 side to the 60 side? You just stick that in front of the square root of 3. So that's 2 roots of 3 in case you can't see it. Boom, done. So the first and the third, excuse me, the first and third examples, super quick. The middle one takes a little bit of work. You have to rationalize your denominator by multiplying by 1 in disguise. All right? So there's your 30, 60, 90 step. 45, 45, 90, only 2 scenarios here. And shouldn't be too bad because you only have 2 different numbers. You've got a 45, and you don't even need to have the 45 written in. If you have slashes maybe, or maybe they'll give you loopies on the angles, like so. Any of those things are equivalent to them giving you a 45 in one of those spots. You got to know it's an isosceles right triangle to apply these theorems that you're dealing with today. And here we go. So the first one, super easy. If they give you a leg, and the legs are the same, so it doesn't matter. If you have a 6 there, you know you have a 6 there. And then the shortcut we talked about a few pages back is you just take that number and you stick it in front of the square root of 2. That's it. Boom, done. And that was from this example. Whatever you had as a leg gets put right in front of the square root of 2. All right? And then if you're given the hypotenuse, well, think about it. To go the front way, the forward way, you multiply by the square root of 2. So to go backwards, you're going to divide by the square root of 2. And this is one of those scenarios where you would rationalize your denominator because you have a radical on the bottom. So which one are you going to pick now? You're not going to use square root of 3 this time because you have a square root of 2 on the bottom. So we're going to pick square root of 2 over square root of 2. Again, that's just multiplying by 1 in disguise, so we're not changing the value of it. Straight across the top, 6 roots of 2. Straight across the bottom, the square root of 4, which is 2. So 6 roots of 2 over 2. Now here's the scenario I was talking about. If your number outside your radical can be reduced with your denominator, then do it, man. So that would just give you 3 roots of 2. And again, whatever you had as one leg, you would have as the other leg. So 3 roots of 2, 3 roots of 2 on both sides. All right, so you might want to keep this video handy, play it over and over until you memorize the 2 scenarios here and the 3 scenarios here. It's just repetition, guys, and it might seem crazy right now, but you will remember it. It will stay with you. If I went and asked some seniors, some juniors right now, they would be like, they would rattle these off and no problem. All right, so second video coming up from 9-2. Peace.